Hi, welcome to Chapter 7. This entire chapter is on triangles and quadrilaterals. This is a picture of the artist Escher. He draws all kinds of things you've probably already seen with steps and ants and Mobius strips, but he has lots of math in his art. And math and art are actually not as far apart as you might think. The logical and the creative are actually connected. But as you see, there's a pattern here of fish and birds. This is called a tessellation, and hopefully this chapter will get to do some tessellations with shapes, not with birds and fish, but you can do patterns with anything, right? And another little connection with patterns is the Bible tells us who we're supposed to pattern our life after. So anyway, I just wanted to show you, this is my favorite artist. He does lots of pencil work. This is one of the few that are in color, but anyway, if you see any of his stuff, you'll now think of geometry, hopefully. So now we are in 7.1, which is titled Right Triangles. Okay, so let's do a quick review of some stuff that we've learned in Chapter 6. Okay, as you see, this is a right triangle, hence it has a right angle in it. Okay? And so angle B is the right angle. Okay, you should know this term already, but like I said, we're reviewing. The side opposite the right angle is called the hypotenuse. It's really important that you remember that term. That's always going to be the longest side on a right triangle. Okay? The other two segments are called legs. And when we start talking about Pythagorean theorem, it's the two legs added together squared plus the hypotenuse, or equals the hypotenuse squared. So we're not there yet, but we'll be working on that here soon. Okay, and let's go over the congruence postulates and theorems that we already know. This is a representation of side angle side. This would be angle side angle, okay, with the included side. Side angle side has the included angle, right? And then we have angle angle side, and we also have side side side. So those are the only four that we know. And now we're going to kind of do a modification. Okay, this is called the hypotenuse leg. That's what the HL stands for, congruence theorem. So if we have a right triangle and the hypotenuse and one of the legs are congruent to the hypotenuse and the corresponding leg of another right triangle, then the two triangles are congruent. So if you think about that really closely, you basically have a side-side angle. The angle you have is the right angle. So as you hopefully remember, side-side angle is not a congruence theorem or postulate. Okay, but hypotenuse leg is a congruence theorem for right angles. Okay, it's impossible to have the same hypotenuse and the same leg with the right angle. Okay, you're automatically going to have that third leg be the same length, and so essentially you're going to end up with side, side, side. But I want you to see the difference. This is the one that is different than the others. Okay, it doesn't line up with another congruence theorem that you already know. So this is kind of the anomaly. Okay, so here's another example of the hypotenuse leg congruence, because see how it's a different leg. It's just another picture for you. Alright, the next theorem is leg-leg congruence theorem. If two legs of one right triangle are congruent to the two legs of another right triangle, then the two triangles are congruent. This one you will see is similar to side angle side. Right? The angle I have in the middle is the right angle. So this lines up exactly. The leg-leg congruence is similar to the side angle side congruence. So again, it's not completely different and unknown theorem to you. It's just worded different for the specific kind of triangle. Likewise, we have hypotenuse angle. So if the hypotenuse and an acute angle of one of the right triangles are congruent to the hypotenuse, and the corresponding acute angle of the other right triangle, then the two triangles are congruent. Let's look at a picture. Lots of big words. Look at a picture. Okay, as you probably guessed, it's side angle angle or angle angle side, right? It's the same thing. So you have a side that's not included in the two angles. Okay, but in this case, because it's a right triangle, it's called the hypotenuse angle congruence theorem. Okay, we're just taking into account that we have a right angle already. Alright, and now we have leg angle. That's what the LA stands for, leg angle congruence theorem. If a leg and one of the acute angles of the right triangle are congruent to the corresponding leg and acute angle of the other right triangle, then the two triangles are congruent. So just, you don't have to write it down, but just think about which one do you think that is. Yeah, angle, side angle. So the leg is going to be included between the right angle and the acute angle. Okay, that's actually the last of our congruence theorems. So for the next 5 questions, I want you to decide if which the right triangles are congruent, and if they are, tell me what theorem it is. Okay, so it's just a multiple choice. I want you to pause and answer for yourself, okay, because that's how you learn, is by doing it yourself, not just watching me do it. So I really expect you to pause and really think about it, and then I'll give you the right answer, and you can see if you got it right. Okay, so is triangle ABC congruent to triangle ABC? Does that help? You say segment AC is congruent to itself, right? Okay, that would be a hypotenuse. You see how it's across from both right angles? And you already have another angle. Okay, try this one. If you said hypotenuse leg, you are right. Now, think about why isn't there enough information here? The main reason is I don't have either of the acute angles, and I only have hypotenuse. I don't have a leg, I don't have an angle, I only have hypotenuse in the right triangle. I have nothing else, so I need at least one other item to be able to call this congruent. This looks tricky because they're overlapped, but so take your time. This is leg, leg, because the XY leg is congruent to itself. So you have two legs on each triangle. Okay, remember the angle that you have is congruent are vertical angles, right? MOL is congruent to PON because of vertical angles. So you have a leg and you have an angle. Okay, so here's your whisk summary. I want you to research the meaning of the Pythagorean triple. Okay, obviously you can Google this. When I say research, I totally expect you to use the internet, that you're not going to go to the library and break out the card catalog and try to find some I don't know, encyclopedia about it. Those old days are gone. But I want you to write out its definition in your own words. That's the important part. Please don't quote what Google says to you, and make sure you have a reliable source. Wikipedia is not a reliable source. Okay, wikis information can change. I want you to find a reliable source, a math website, or a college website. Something with edu is always good. It doesn't have to be, but something reliable. And then find 3 examples of the Pythagorean triple. Okay, and submit that to me email, and I will see you in class.